All right, so to begin with, let's talk about what we did yesterday. When you had a problem like this, x plus 3 and x squared plus 2x plus 1, you just factor it first, and you get it down to this, x plus 3, and then x plus 1, and then x plus 1 greater than 0. Now, I was talking to you about how the roots of this are easy to find, -1 and -3. So here's -3, here's -1. And I was talking about it in terms of testing points. And at the end, I showed you, look how you can graph it. And when you graph it, it gives you the answer graphically pretty easy. But I want to talk to you about how to do it with graphing, even when you can't use a graphing calculator. Because graphing is the best way to do this. Like, for instance, if I had this graph and I knew that it had to be going up on the right and going down on the left, and that there was a bounce at the -1, can you see how that graph would have to look? I can see. It would go boing, and then it would go up and then back down. And if I knew that, wouldn't it be really easy to tell where my function was bigger than 0? All of this time, it would be bigger than or equal to 0, except that one spot right there, it's equal to 0, because that's one of the zeros, right? So then my answer would be, for this question, I would say it was greater than 0 from -3 to -1. And at 0, it doesn't work because it doesn't have an or equal. So I'd just like this. And then I'd say union with -1 to infinity. Are you able to read that? Okay, so I'm going to give you another one where I'm not even going to give you the problem. I'm just going to give you the graph. And if the graph looked like this, there's a bounce at -2 and there's a cut through at 7. You get where I'm going here? Now, what if I said, where is the function less than 0? Answer on your paper. Where is this function less than 0? Now it says it's less than 0. Less than or equal to. It'll be different. You get that it's only in here where the function is less than 0. So you should have said it was less than 0 between 7 and infinity. Raise your hand if you did that one right. Good. Now what if I had said or equal to 0? Then that would change it, right? I would change it so that this spot would work and this spot would also work. Then I'd have to say that it works at -2, because that is equal to 0. Union with, that 7 now works to infinity. Get that one? All right, sit down. When you see today's homework and it's got problems like this, can you make a quick sketch of that for me, focusing on the roots? So find your roots and then make a sketch and make sure you see that it either goes, is it bouncing? And then I'll say we want the stuff that's less than 0. To start with, you don't even care about that. You just graph it. Don't worry about the 0. Just should you get 2 is an important spot, and -3 is an important spot. Now the sketch of this graph, is it going up on the end, on the right-hand side? Yeah, because if I take my lead coefficient numbers, that, and multiply them, I get x to the third, and it's positive. Therefore, the lead coefficient of this thing is positive. So if it's positive, then it must be going up on the right. It's got to be going up over there. It's got to be bouncing at 3. Did you make your graph like that? That's what you should have done. Why is it going down on the left? Because it's degree 3. It has to go in opposite directions. See? One end's going up, one end has to be going down. Now that I got my little picture for it, answering the question's easy. I don't have to test intervals anymore. Isn't that cool? I don't have to try, okay, now stick in 3 and see what you get. Now stick in 0 and see what you get. Now stick in -4 and see what you get. This graphing thing's way faster. All right, so now I can say, all right, my answers are less than 0 in this little zone right here. See, they're dropping into the negatives. And this zone right here. And what about 0 itself? We don't want zeros, because this doesn't say or equal to, it just says less than. So we want to say from negative infinity up until negative 3, union with negative 3 to 2. And as soon as I change this to a or equal to problem, then I'd say, and it works here, it works there, and it works there. I'd have to have brackets everything. And would I even be able to just simplify that further and say it's negative or equal to 0 all the way from negative infinity to 2? Yep. That's also right. Oops, always have parentheses. Okay, so the point here is you don't have to test every interval. It's a good way to do it, but this graphing way I think is better. Because honestly, I've seen tons of kids make mistakes on testing their intervals. They've got this thing, they know that it's this, this, and this. And almost everybody gets the zeros right. And then let's say they were testing negative 7, 3, and 5. And they'll get that these don't work, and then they'll test this, 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 and this. Can you see a kid making a mistake on testing one of those intervals? Yeah, that's all it takes, and no problems are. Okay, and so I think it's better to do this graphing deal where you go through here, it bounces there, and then it has to end going down. And how do you know it ends going down on the right? If the lead coefficient is negative, it has to be going down. All right, the only other thing I want to talk about is what happens if you can't get any roots? Okay, you're supposed to set these equal to 0 and solve them. X squared plus 1 equals 0. X squared equals negative 1. Wait a minute. Is that even possible? Anything something squared equaling a negative? It's not possible. That gives you an imaginary answer. Square root of negative 1 is called I. There is no spot for I on the number line. We don't know where it is. Okay, so that's imaginary. This one you might think is going to be real. I thought it was at first. And then I moved the negative 2 to the other side. And then I divide by negative 3. And all of a sudden I'm back in the same kettle of fish. When I do a square root of a negative, it's not going to be possible. So I don't have any roots. What am I supposed to put on my number line if there are no roots? Yeah, see, think about it. There still is a graph for this, isn't there? There's a graph for everything. So if there's still a graph for this, do you get that this graph then never touches? So it's either all above the line like this, or the graph might be like this red one, where it does its thing down here and it's all below the graph and it never touches. So either it's always positive or the answer is always negative. If you're not sure which of these two it is, the red graph or the blue graph, this one or this one, how could I tell? What if I just told you that it ends going down? Can't you tell where the graph has to be there? If it ends going down, it can't be this one. It has to be this one. So let's look at the lead coefficient on this and see if it'll tell me whether it ends going up or down. Take that, I times it like that, and I get negative 3x to the 4th. That tells me both ends are going either up or down. That makes sense, because if it's never going to cross the line, they're going to have to either both be up or both be down. And since it's negative in front, it is the red one. It has to be going down on the right-hand side, so it has to be this one. You get that? So now I know it's below the line. So what's the answer to the question? It's asking, when is this function here greater than 0? It never is, so there's no solution. What if they had asked you, when is this function, change that to a less than, rotated up on a plate. There we go. There, now if it says less than 0, when would it be true? All real numbers would work, or you could say negative infinity, positive infinity, because it's always below 0. Okay? All right, and then last, what if they have like a little hybrid of this, where they say or equal to 0? Is this thing ever equal to 0? But is it ever greater than 0? It's two separate questions. Is it ever equal to 0? No. Is it ever greater than 0? No. So the answer is no. It never will be. So then the only last combo is that. Is this thing ever less than 0 or equal to 0? That is. It's always less than 0. Doesn't that or equal to 0 doesn't even matter because it's an or question. It's this or this. And it is. So the answer to that question would be always less than or equal to 0. Okay. So now, the only other thing is, you know, some kids get them when I give them really easy ones like this. But because they can get the roots of that easy, they go, oh, x equals 3. And some kids are still stuck in this x equals -2. That is totally wrong. How do you get this right again? So it equals 0, and yes, it would be -1/2. 2x plus 2 equals 0 is what you start with. Then you move the 2 to the other side. 2x equals 2. And then x equals, wait a minute, -2. 2x plus 2 equals 0. Right? And then subtract 2, yep. And then -2 over 2. And, wait a minute, so what am I doing wrong here? Is x equal to -1? I thought it was, oh, somebody said it. I was thinking they were right, but they're not. If I put in a -1 here, will this thing equal 0 then? -2 plus 2, yeah, it equals 0. There's my answers, there and there. Now I can go on to my number line and test intervals. What did I just teach you that was smarter than testing intervals? Graphing it quick. Okay, so let's do that quick. Draw the number line. -1, 3. And would this thing end going up or down? Up, because its lead coefficient is positive. So it must be going up. Does it have any bouncing going on? Nope, so none of them are squared. So then it must be cut through again. Does it make sense that it's going up on both ends? Yes, because it's an even degreed polynomial. It's a degree, lead coefficient here would be 2x squared. It's even, so they must be both up or both down. And the lead coefficient is positive, so the end is up. So it has to be like that. So now if I was asked, is this function, when is this function less than 0? I'd say between here and here. If I was asked, where is it greater than 0? I'd say from 3 to infinity and from -infinity up until -1. All right, I want to give you one to try. Everybody on the notes I asked you to take out, try this one. X squared plus 1, and then x minus 4 is greater than or equal to 0. Make me a sketch. This is going to freak some people out, but try making a sketch. No, you can't graph imaginary numbers, so don't worry about them. This part's the imaginary part. You can't get an answer for that. So just ignore it. Okay? You're not going to need a root for that. This one's root's easy. It's 4. So there's one off 4. Now, can you sketch me the graph of it? Is it ending going up or down? Is my lead coefficient positive or negative? That times that makes x cubed. Is my lead coefficient positive? Yes, it is. So it must be going up. And then it's degree 3, which means it has to be going down over here. Could it be just as simple as that? Yes, it could. Technically, I want to make that like a little snaky one. So I should probably be a little more careful as I draw it. There. Now, where is it bigger than or equal to 0? Before infinity. Does it work at 4? Yes. Because why? It's not equal to it. Or another way to check it, put in a 4 here. You'll find out that the answer's true. All right. Now, if you don't like this graph thing, it still works. You can test 5. Test -3. Test 0, whatever's on the left of 4. And then you'll find out that it works with 5, and it wouldn't work with -3. And that's an okay way to do it still, but I think this graph way is way better. All right. Now, are there some on your worksheet where you actually have to graph them? Yeah, because they're just so nasty you can't even tell what they look like. So you don't know what the roots are. So So like if it was x to the fifth plus 3x squared plus x minus 17, you're going to be graphing. And once you graph it on your calculator, it looks like that kind of thing. Okay, so maybe they had 3 real roots and 2 imaginaries. So let's say it looks like that. And then they say it's greater than or equal to 0. And I'd say the answer was from here up, but also that spot. A lot of people forget that spot, because that is the spot it's equal to 0. So let's say that spot's at 3 and the spot's at 7. I would say my answer would be it works at negative 3 union 7 to 80. I still made a mistake. Bracket on what? Okay. It's the 7 letters. Okay? I did not do an accurate graph of this. I was just saying if you graphed this with your calculator and it looked like that, then your answer would be this. But I have no idea what that looks like. You have to graph it yourself. All right, let's do the first couple problems off your worksheet. Here it comes. Number 9 on this worksheet. Help me remember, number 9 is one you can skip because it's a flawed problem. It doesn't have a greater than or equal to sign, so you couldn't have done it anyways. So skip number 9. Hand these all the way back up. I'll bring you yours in a minute. Okay, the very first one is one of those weird ones where it has no roots. So let's do that one together. Here we go, number 1. X squared plus 1. And then negative 2 minus 3x squared is greater than 0. And I'd save you some time. We just did this a second ago. Do you get how that's imaginary? You can't make this equal 0. Because you'd need to have somehow this whole thing would have to equal negative 1, and that's not possible. And this is also imaginary. So when you graph it, it won't ever touch. So then the question is the whole graph above it, or is the whole graph below it? You could test any point you want and see if the answer comes out positive or negative. Or you could think, what's my lead coefficient? Lead coefficient here, this would make negative 3x to the 4th. That tells me everything. Can you see it has to be going down at the end? Because the lead's negative. So it must be going down. If it's going down, then the graph must stay down here underneath the line. So then what does that tell me? Is this thing ever going to be greater than 0? No, so you can say no solution. Now, problem number 2, exact same question, except it says greater than or equal to 0. Or is this thing ever equal to 0? Okay, so now you got your answer. Number 3, it says it's the exact same problem. It says less than 0. It changes the problem right here to be a less than 0. Well, if you know the whole thing's underneath the line, you should be able to tell what your answer is really easy. All right, and number 4 is also the same basic problem again. So once you know that thing is all underneath the line, it tells you everything. Let's move on to number 5. Number 5 together. It says x squared plus 4 again. Does that mean you stop the problem and everything's imaginary? No, that means that one's imaginary. 3 minus 2x squared is going to be greater than 0. So then this part's imaginary, true that. But how about this part? Can I make that 0? 3 minus 2x equals 0. Solve it right now. Can you get an answer? I got an answer. What does that mean? There's a root. There's a 0. It touches at 1.5. So then, here's my 3 halves. Does it work at that spot? That's a 0. If I make this whole thing 0, does my equation work? No, because it wants it to be greater than 0. So 0 is not greater than 0. So bottom line is this doesn't work. Empty spot. And then now if you want to do the graph thing, go ahead. If you want to test a point, go ahead. What do you want to do? Should we graph it? All right. Our lead coefficient then, we need to know that, is this times this, which would be negative 2x to the fourth. That tells me f. It ends going down. Okay. This looks negative. It ends going down. Where it touched, was it a bounce there? So it bounces here, and then it must go back down again over there, because it is even, and that means that both ends have to do the same thing. So there's pretty much my graph. And now I hope you can answer the question. When is that thing greater than 0? Never. It's always underneath the line. It touches the line, but that's equal to 0. It wants to know when it's bigger than 0. All right. Remember, skip number 9, and then flip to the back side with me for a second. 11, 12, 13, 14. You're just going to type them into the calculator. You're going to sketch what you get, and then you're going to answer the question. When is that function less than 0 or whatever from your calculator? And then the last thing is 15 and 16. I want you to wait on those. It's not that I don't want you to do them, but you don't know how yet. And I'm going to teach that tomorrow. So those that are missing tomorrow, you definitely want to watch the video, because even I don't remember exactly how to do those yet. I'll figure it out by tomorrow. But I can't remember how to do those right off the top of my head. So I was going to maybe show you one, but I get it half right, and that's worse than just waiting till tomorrow when I do it right. Okay, so just wait on 15 and 16. You don't need that till tomorrow's lesson. All right, that's all I got for you for today.